Next we have stability. So a state is considered stable if no decision maker has any incentives to make moves to a more preferred state. So this is also known as Nash stability or an equilibrium, and this is the standard equilibrium that we have. We have variations. There are a lot of variations, but today we will be talking about two variations from Nash's stability. First one is meta-rationality, and the second is sequential stability. These two variations are more complex. They account for strategic moves by the opponent, and they allow for more unilateral moves to be had. So looking at the table below, the first stability we have is Nash. Its description is that a decision maker cannot make unilateral moves to a more preferred state. Compared to GMR, general meta-rationality, it is a unilateral improvement, but that can also be blocked by other unilateral movements by the opponents. So even though your opponents do not know your preferences prior, but they can see your unilateral movement, and they can negate the improvement that you have made by them making their own movements. You are only allowed a certain number of moves, typically 2 moves, and as we can see, this stability is more strategic, more dynamic than Nash's stability, and it can be applied in more complex games. And then we have sequential stability, which is similar to GMR in some ways, but it's less complicated. So it's described as unilateral improvements can be blocked by subsequent unilateral improvements by others, just like GMR, but the difference here is that the players have prior knowledge of the opponent's preferences before they make the move. So you can optimize after every transition, and that makes it more predictable than GMR, because with GMR you have no prior knowledge of the opponent's preferences. Another difference with GMR is that with SEQ you cannot disapprove of transitions. Yeah, so I mentioned that GMR is the more complex stability. Yeah, but I think SEQ is the more complex one compared to GMR. Yeah, just because of the fact that you cannot disapprove uh, uh, the other transitions. Yeah, and with that, we will get to, and lastly, we have applications. And the first thing I want to mention is something from earlier on that we talked about, which is the fact that GMCR accommodates ordinal information, ordinal preferences, and you can also say imperfect information. And so that makes it inherently practical in real world uses, at least compared to game theory models. Uh, but with that being said, I am yet to see empirical evidence, research that has proved its capability of solving conflict without using other means. Uh, uh, in addition to it, uh, I think it has proven its utility in theory and in predictions, in analysis of conflicts, which by itself is very useful. But it's still not a comprehensive tool uh, for conflict resolution. Uh, and with that being said, I would like to mention three cases where it has been utilized, and I believe it has been useful in these cases. So the first case is the acid rain dispute between Canada and the United States. Uh, so this was a transboundary dispute, 20 roughly 20 years ago. Its cause was American industrial waste, uh, fumes and exhausts that uh, uh, traveled to Canadian territory, and it affected the wildlife there, the ecosystems, and so it caused a dispute between the two governments. And so for this case, the uh, uh, graph models were used to analyze the preferences of the decision makers and to predict the outcomes uh, of these preferences, and that helped to shape the negotiations. But as I mentioned uh, before this case, this was not the only tool that was utilized. Of course, there was typical diplomacy and probably other means of negotiations, but this was a tool that was used in this conflict. The next case that we have is the NAFTA agreement, the original negotiations. These happened in 1993. and these were very complex negotiations. It's a three-country uh, trade agreement. The countries are Mexico, United States, and Canada. Yeah. And the graph model here was also utilized in a similar way to the uh, previous case. Yeah, uh, but as we know that uh, this trade agreement is highly controversial, and even after it was signed, it was criticized immediately, and it's still being criticized until today. And so we can draw from that that we did not get a solution uh, uh, from the graph models. But as I mentioned, it was likely helpful in shaping the agreement, uh, uh, perhaps in from efficiency standpoints as well, which are modeling some information that would otherwise take a lot more time to, uh, to negotiate. And lastly, we have the Iranian nuclear negotiations. And I think everybody knows that these haven't been going so well. So for this case, the graph models were used on the uh, older negotiations, which have resulted in a deal that has been signed by Iran and the other parties involved. But that has also not been a convincing settlement, because the United States withdrew from the deal shortly afterwards, uh, which doesn't necessarily indicate that anything was that there were issues with the outcome. It just shows that there are a lot more aspects that the graph models cannot uh, integrate in their calculations. Yeah. And these limitations are what at the end uh, limit its use or its utility. Yeah, and what else do we have? So at the end, I think we can summarize GMCR into three fundamental points. The first, that it's stakeholder based. The second is that the preferences are relative, ordinal. And the third is that it is quite adaptable to real world scenarios. These are the references, and this is all. Mm. Thank you for listening.